Hi, this is Jihan, and today I'm gonna talk about my project 5 in my independent class. So the topic is infinite stack and the finite stack. So what difference between finite stack and the infinite stack? So finite stack, we use array to define the capacity, right? So imagine there's a container and there's like a separate we use array to define the capacity, right? And the finite class and that means the finite, and the infinite means unlimited. So we don't need to care about the size of the array, right? But here we have to declare the size, like how many size, maybe 5,000. Yeah. But infinite, we don't need to care about the size. We just use the link to connect each node. Yeah. And what else? Yeah, that's basically the different finite stack and the infinite stack. All right, let's see the code. So the first one I'm gonna talk about the finite stack. Okay, finite stack. I have a finite stack .h, the class file and the CPP file and the min.cpp, and I made a make file, right? So first one, going to my see my finite stack. So I have a private function and a public function. So private function integer pointer p array. I have to declare the p array because it's a finite stack. We're using array to store the data, right? And the integer size, the size of the array, and the TOS, that means the index of the top of the stack. So just the top of the stack. We have to remember the top of the stack because in the give me a second. Yes, in the stack is the last in, first out, right? Last in, first out. So yeah, we have to remember the top one. And there's two operations of the stack. One is pop, another one is push. Pop and the push. And push means insert the data in the stack, and the pop is remove the data or take the data from the stack. Yeah, that one is the add, that one is remove. So yeah, basically, yeah. And the constructor, I have to take the constructor integer, and constructor take the integer, which is the size of the array. Yeah, because of the size. So just put the integer, and the destructor, I have to free the memory. Yeah, free the memory, and the boolean empty and the boolean full function. Those two are kind of similar, and use the const because we don't change the data value. If the stack is empty, so we're going to the function, or if the stack is full, so we are going to the implementation, and avoid the push and the pop and the top. Okay, and going to my fstack.cpp implement. And here I have to include the fstack.h, the class file, and the c assert. What is c assert? Is used to test assumption made by programmer. For example, we might use assertion to check if pointer returned by the constructor is none or not. So that means just the check. Yeah. the first one, my constructor, and set the constructor value, right? The size, right? Integer size. I talked about that before. And size equal to s. And the p array equal to new integer size. P array, that is the new array, and equal to the new integer size. And the top one equal to -1. Why is a -1? Because of oh, sorry about that. I'm losing. Okay, so keep going. So the distractor deleted the array, deleted the array, delete the p array, the whole array, right? And the fstack boolean function if the stack is empty, so return the top to the -1. So return the top of a stack to the -1. And the boolean fstack full function const, and if stack is full, return the top of the stack equal to size -1. That's the full condition. All right. And the top one, so the top is very important in the stack because we need to take the we need to pop or push anything of the top. Yeah. And the third, if not empty, so return p array, and the top of the stack, return the p array, the top of the stack. That means the top one in the array. And the next one is the fstack push. Push means insert the value in the function in the stack. Same thing, integer data. And third, if not the full function, and the plus top of the stack is it means the stack, check the stack if not full, so plus and the p array at top of the stack equal to data, right? That's the condition, like the precondition. Yeah, that's the the precondition. We have to use this condition because the push that cannot be full, right? And the pop is remove the value, take the value from the stack, right? There's still the condition, the precondition, and yes, if the stack is not empty, so the pop can work. If the stack is empty, so this function is not gonna be work. So that's assert, and the minus top of the stack, right? And right now going to my main function. So my main function basically just test the stack, right? Is nothing special. So integer fstack s1, the operator size 5, right? Create an object with 5 elementary of the array, right? The size is 5. So assert s1 the empty, and the assert is not full. So that's the precondition. So this whole part can work. All right. So s1 push 10. So push 10. So the 10 is gonna be the first one. Let me draw the one. And the assert as right here is the top one is equal to the 10, right? So see here is push 10, and the 10 is gonna be the top, and the pop, and the third empty, and push 5, 6, 7, and the right now the top is 7. Why is not 10? Because I have a pop, so pop 10, yeah, and the top is equal to 7 right now, and the pop So the top is gonna be the 0. Oh, no, oh yeah, right here the second one is going to the second one, the 6. So the top is gonna be the 6. It's the last in first off, so it's the last one. 7 is gonna be the top, and whenever we pop the 7 and going to the next one, so the top is gonna be the 6. That's how stack works. And yeah, and I just put another test, yeah, like a larger the data, and the size is 2000, and I have stack empty, and there's a loop. Yes, after loop done, we need should be the empty. Yes, and make file. Yeah, let me take this. Let me check that one. Yes, so everything works in my infinite stack. All right, right now I'm going to my infinite stack. Infinite stack. Yes, infinite stack. So as I said before, what is an infinite stack? So infinite stack is an infinity stack. We don't limit the size or capacity, right? But we yeah. We just it's an infinity class, right? Oh yeah. Infinity class. We have to define the capacity at the beginning and just allocate the memory dynamically. So this is different with the finite stack. All right, going to my age. Oh, sorry, my makefile didn't put a clean, right? So just use clean, remove. So make it clear. And so first one going to my infinite stack.h, right? So programmer ones. What is the programmer ones? Yeah, the programmer ones is on editor for each class definition. So just define the ones. So in this class, and infinite class include the node.h. Let's see the node.h. So imagine I have a node, right? So what is under the what are the under the private? I have the data, integer data, yeah, and the node pointer link. What is a link? The link is just connect to each each of the node, right? The link to another node constructor, and the public and the node integer, that is the data. Yeah, and I use the friend class right here. So yeah, I'm gonna talk about the friend class later, okay? And going to my infinite class, and include the node.h and the class infinite class private. What is under private? So the node pointer p top. Yeah, I have some pointers, the top. Okay, and the public constructor, destructor, and push and pop and top full and the empty. I already talked about all the operators from last video, from finite stack. So it's basically the same. There's one thing I need to mention is the node pointer of p top. Okay, and going to the CPP and the yeah, the constructor p top equal to non-pointer. The y, because there's remember this one. I need to draw the one. So infinite stack. Yes, infinite stack is the limit, right? No. Oh, the infinite class. Yes. Infinity. Yeah, it's not gonna limit the it's not gonna limit the size or capacity. So there's some single link to connect each node, right? So the p-top equal to non-pointer. That's the constructor value. The link member is initially non-pointer. And the destructor, if there are any node are not free to yet, by the time infinite stack object dies, we need to free the memory. That's constructor does, right? So use a while loop. If not empty, so pop. So until it's empty, this constructor just free the memory or just delete the heap area, right? And the push function. The first one to create a node structure and the data and the link. So the node pointer node new node equal to new node data. Put the data integer data in the constructor. And if p-top equal to non-pointer, so p-top equal to the when the p-top is not when the p-top equal to 0, so the p-top is gonna create a new node, and else, so new node point to the link. Because we have the sum of the link is hold the address of is hold the address from the last top. Let me draw the picture. How can I delete? Eraser. So complicated. Sorry. Yeah, alright. Okay, alright. So like infinite stack, like S1, right? That's the object S1. So S1, I have a push, right? I have one push 5. So that means there's gonna create an like a 5 in the stack. This is the 5 in the stack. And whenever I pop the 5, so the 5 is gonna be wiped out, right? But there's still one like of the what's it called? Like the address of the link, like the node. The value is gone, but the address is still there. So that's gonna hold the link is gonna hold because 5 was the top, so the link is gonna hold the top from the last top, right? It's gonna be the new top. It's gonna be the new top, yes. And the top, let me see. Oh no, this is a infinite stack. What is the infinite stack? Oh yeah, infinite stack is right here, sorry. And the pop, push and the pop. So I use a pointer, so remember this operator, the arrow operator, so the new node point to the link, we have to use the arrow, so link. That means the update the copy of the link member of the new node, just only update, and everything done. So the p-top equal to the new node. Don't forget about that. Yeah, that's the precondition should not be empty. If if the stack is empty, so this whole function is not gonna be worked. That's the pops means. The pop just remove the function from the remove values from the stack. So imagine if the stack is empty, so the pop is do nothing, right? And if the link is going to the non-pointer and the delete, don't forget the delete, because we create a new node. We already created a new node, so don't forget to delete the top, right? And I also create a pointer when I want to store current p top, the last one, the last top, right? So node pointer discard equal to the p top, and the p top point to the link, and delete this discard, free the memory, right? And free the memory, and as an empty, return p top, and equal to full, and return false. So no more memory from the computer is available, so just equal to false. Or we can say, let me see, we still can say something else, like when there is a full, so we can return p top p top is equal to non-pointer. Oh yeah, that's and the top one, the precondition is not be empty. If the stack is empty, but there's a no value on the top, so right, so return p top is equal to the data. And my main function, my test function, just consider integer n, that's the size, like 5,000, right? 5,000. And the object s1, create an object, and the third f, that's the precondition, is empty or not full, or it's empty, so that can work. And the for loop, s1 push I, and the third is not gonna be empty. When loop is done, s1 should not be empty, right? Because the push, we have to push something is not gonna be the 0, at least the 1. And that one, when loop is done, s1 should not be empty. I marked the wrong way, wrong line. It's gonna be this line. Another for loop, and n minus 1 and I larger and equal to 0, and I minus minus, because that one is the pop, it's not the push, so just opposite of the push. So assert as one top, just the precondition, right? The precondition as one top equal to I. So this can work, because the pop need to pop something inside of the stack. If the 0, this is not gonna work. So as one pop, and everything done. Don't forget about the loop. When loop is done, should be the empty. So don't forget about the line 24. That's the common mistake. We usually make this mistake. And let's try the code, right? Istack make. Yes, it's not it's worked. All right.